Hello everyone, welcome back to the channel. So today we'll be looking into the most important graph algorithm, that is Prim's algorithm. So this gives us the minimum spanning tree, that is MST of a graph. So in simple terms, it refers to connecting all the vertices. So it connects all the vertices, and the second one is it should connect with the minimum possible cost. So it should connect with minimum cost referring to the weight the graph has, the weight on the edges. So that we'll be looking into the example now. And the third one is it should not have a cycle, so no cycle. So these three are the conditions. So now we will be looking into an example. So node 1, node 2, node 3, and node 7 here, and it should have weights on it. So I told the input should be always a weighted graph. So here it is 28, here it is 16, 12, 11, 10, 25, 22, 24 and 18. So this is the given graph and we have to find the minimum spanning tree. So starting from node 1, we have two possible edges, that is towards 6 and towards 2 with weights 10 and 28. So we'll choose the minimum one. So we'll go to 6. From 6 there is only one possible way, towards 5, that is 25. From 5 we have 22 and 24. We'll choose 22. And from 4 we'll go to 3 with weight 12. From 3 we have only one possible way, so we will go to 2, and from 2 we will go to 7, that has 11. So now that we found that we connected all the vertices and we took the minimum cost, like we considered the minimum weight on each edge, and there is no cycle. So cycle refers to any polygon that starts and ends with the same vertex, or any other polygon like hexagon. So here the starting vertex was 1 and the ending vertex is 7, and there is no cycle present. So it satisfies all the three conditions. And to find the minimum cost, we have to add all the weights that we got, the minimum weights what we got in our spanning tree. So these sums up to 96, and therefore the minimum cost, so the minimum cost of the minimum spanning tree is 96 for this given graph. So we need to write a code for this algorithm. So let us look into the code now. So here is the given question. Find the minimum cost spanning tree of a given undirected graph using Prim's algorithm. So whatever the graph we just saw was an example of undirected graph. So we look into the code now. I have created a package. So you also may or may not create a package, and also can directly go with creating a class. So I am using Eclipse IDE for running the Java code. So we have to import the inbuilt Java class for taking the user input. That is, we will ask them to give the number of nodes and then the adjacency matrix, which which has the cost or the weight of the graph. We just wrote it in the form of a graph that will be given as input through adjacency matrix. Before that, we have to take the user's input to know the n, that is number of nodes. So we'll import the scanner class, then we'll go to the main class. So here I have given the file name as Prim's class, and this main class name has to be same as the file name. So keep that in mind, and then we will declare few global variables, that is an 2D array, and the 2D integer array naming as cost, and a integer n which holds the number of nodes in it. So we'll go with the function, main function. Now we will define an object to take the input from the user. So I have named it as SC. So I will be using SC dot the data type while taking the user input. So system dot print, enter the number of nodes. I will use n to take the input, and the inbuilt class next int to take the integer out. So it has similarly next float, next double. So we'll be using that. And here the cost is an array with the size n plus 1. And we have to take the user input, that is the adjacency matrix. So we'll be writing a statement for that. Enter the adjacency matrix, and while taking a array, that is 2D array, we'll be using two for loops, that is from I is equal to 1 to I less than or equal to 1 and I plus plus. So why did we use n plus 1 here is that we start from 1 and end with 1. So if we take n, it will be starting from 0 to n, but we want the adjacency matrix to be written from 1 to the nth element only. So the number becomes n plus 1. I'll be showing it in the explanation part. So for int I to 1 to less than or equal to n, next one is j from 1 to less than or equal to n, and j plus plus. Will be incrementing I and j, and we have to take the input, that is cost of I j is scanner dot next int, and we'll be checking that if cost of I of j is equal to 0, then make it as cost of I of j is equal to 990. That is, if there does not exist any edge, we'll make it as infinity. Infinity here we are denoting it by 999. And then we will call Prim's algorithm after Prim's class, that holds the Prim's algorithm after the for loop. And now we will be writing the code for that Prim's class. So This was our main function and this is our prim's function. Here we need another integer array which holds the visited values, again n plus 1 size, and we have to hold the minimum cost that is initially 0, and another one is this is ne is equal to 1 is number of edges that is initially 1, and it will be keeping track of how many edges have been added to the MST so far. So that we will look into later. Initially, the visited has to be 1, and while number of edges visited is less than the total number of edges, then we have to assign minimum with 999, that is infinity, and u is equal to 0 and v is equal to 0. So these two are the other two variables we'll be using to traverse through and assigning the values of I and j respectively to u and v whenever needed. So again, to traverse we take I is equal to 1, I less than or equal to n, and I plus plus. If visited of I is equal to 1, then for int j is equal to 1, to j less than or equal to n, we do j plus plus, and if the cost of I and j, that is we check each one, is less than minimum, so we have already assigned a value, and if this is less than minimum, then we will be assigning minimum with that cost value. So this is again a type of brute force approach. We'll be checking one by one with minimum having a value firstly, and then it checks with the cost of I and I of j, and it will be assigned to minimum if it is minimum. So this condition checks if the cost of I comma j is less than the minimum, and if it becomes true, it will be assigned, and we will assign u with I and v with j. So that particular I and j values here, that will be assigned to u and v, and that will be considered when starting from the loop again. So this is inside the loop and it will be starting again from here, and those new values will be considered. So after the for loop, we will go for if visited of v, that is the jth value, is 0, then we will be printing the values. So that we have found the minimum cost. So edge, number of edge, so this is all the formatting that how the output should look like. So we'll be adding youth value plus a comma and the v value. We will be closing the bracket. The bracket here inside the double quotes is what it has to be printed, and after that the cost has to be printed, that is the minimum cost what we got. And we have to add all those minimum cost at the end. So minimum cost is equal to minimum cost plus minimum. So for every, sorry, minimum cost is equal to minimum cost plus minimum can be written it like this with a shorthand operator. So this plus is equal to is a shorthand operator, and we will make that visited of v is equal to 1. So that is, it is visited. So now after this we have to make this cost of u comma v is equal to cost of v comma u is equal to 999, that is infinity, and we will be printing the final minimum cost, that is what we got as 96. So that will be printed using this line, and here it ends the code. We will be running it now. So enter the number of nodes. So we'll take the same example we just looked into. Number of nodes was 7, and to enter the adjacency matrix we will be looking into, for any edge that does not, like 1 to 1 was not a, like it did not have an edge from 1 to 1 itself, so that should be taken as 999. And then for 2 it had 28, then 999. So after entering all the cost of the edges given in the graph, we'll get the output like this, that is edge 1, that is will go from 1 to 6 with cost 10. So the second edge what we traversed is from 6 to 5. So 1 to 6, then 6 to 5 with cost 25, then from 5 to 4 with cost 22, and so on. From 2 to 7 the cost was 11 and the minimum cost is 96. So this is how we get the output for the Prim's algorithm. So I'll be posting a photo of the explanation how we wrote the adjacency matrix with the graph at the last. Thank you for watching, and please subscribe for more such videos.